Yeah, welcome again. Welcome to Tone Academy. I'm Chandrasekhar Vadlamani. I think just we wanted to recollect what we have done yesterday. We are actually dealing with atomic structure. So many things we have discussed, and if you are following the sequence, I think you can bank on us, right? So my advice to you is you might be listening to classes in your respective classrooms, but I think you can sit down, relax, and just subscribe to Tone Academy and follow chemistry. That will be just enough for you to writing your aptitude test. That's nothing but your JEE mains or BITSAT or whatever it is, right? And then taking a little bit forward from Heisenberg's uncertainty principle. If you have not followed, if you have not joined me, just go through the Heisenberg's uncertainty principle. You know what he has done basically is he is contradicting the Bohr's theory. We were so proud about Bohr's theory because he is the one who has proposed the non-radiating paths. And when you propose non-radiating paths, I think the energy of the orbit or the shell or the non-radiating path will remain constant. So what is the basic gist of what Bohr wanted to tell is basically, if you ask him, where is the electron, then the electron will be residing in the shell. That's what is the contention of Bohr. So in fact, he's not telling because he was actually calculating it. Start from the nucleus, get down to the 0.529 angstrom units, you will get what? Electron. If you complain that you don't have the electron in the first shell, get into the second shell. And if you don't have in the second shell, go into the third shell. That means he's indirectly giving you the address of the electron. The electron will be basically present in the first orbit or the second orbit or the third orbit, not in between the orbits. So he was very convinced when he was actually proposing his theory of non-radiating paths. That's what we were discussing in Bohr's theory. Here comes Heisenberg's in the last class. If you have not joined, check out what I'm telling, right? This guy is basically going against what? Your Bohr's non-radiating path or the Bohr's theory, you must understand. He says that it's basically impossible. Now, when he's using the word impossible, he's not using the word difficult, right? He's using the word impossible to determine the exact position and the velocity of an electron like a subatomic particle like electron. It's impossible to determine both at the same time. At the same time, determining position and the velocity or the momentum is just not difficult, but it is impossible. But let me tell you that these have been actually derived, and just for your recap, if you actually see the position is nothing but the distance of the nucleus to a particular orbit. That's the position, right? And I think we should be proud of, because atom is invisible to the naked eye, but someone has actually calculated from the nucleus to the first orbit, nucleus to the second orbit, nucleus to the third orbit, like that, right? We should be proud of him. Now this radius equation, if you see, the radius of the first orbit is basically 0.29 angstrom units, and he is so proud that he has found out the position. And he is claiming that, right? At the same time, he was also telling velocity of the electron in the first orbit is basically 2.18 into 10 power 8 centimeters per second. And look at this. Both the position, that is the distance from the nucleus to a particular orbit, which is measured in centimeters, and then he simultaneously is actually finding the velocity of the electron, right? And he has published it. And now comes Heisenberg. He says that to determine the electrons, this is only applicable to electron, which is a subatomic particle. Atom itself is invisible, and we are speaking of electron, which is subatomic particle. And mind you that electron's position, that's nothing but the radius, and the velocity determination, both at the same time, he says it is impossible. Now look at the sequence. First was Bohr, and then comes Heisenberg. So it's basically Heisenberg's theory was proposed little later from Bohr. So what happened was basically the Bohr is in the line of the fire of Heisenberg, because someone has claimed I have found out, someone has claimed that he has found out radius, and he has found out what? Even velocity. But someone is again coming and telling that it's not difficult, it's actually impossible. Right? And we are confused. And mind you, in the last time, I think I was telling you that yes, his theory has significance. His theory has significance, and it has significance for subatomic particles. You must understand this, right? And now after Heisenberg, I just don't want to get into the details of the last class. You can actually check it out, right? What was discussed in Heisenberg's uncertainty principle. Now, once the Heisenberg's uncertainty principle was taken, then the doors for certainty of an electron has been permanently closed. The doors for certainty with regard to electron. Now, what are the doors for certainty with regard to the electron is finding its position, and claiming that it is 100% accurate without any error is nonsense, says Heisenberg. Right? Similarly, if someone is claiming that I have found out velocity and claiming that it has no error, right, or a minimal error which you can actually discount it off, is absolutely nonsense, says what? Heisenberg. Now what happened was, after Heisenberg, people used to not talk with respect to electron with certainty, but rather they have started talking in terms of probability. In terms of probability. That's why, if you actually recollect, your teachers were telling something about the definition of an orbit. And what is an orbit? Orbit is a place where electron spends maximum time, or 99.99% probability. Is not telling 100%, like the Bohr was claiming that he has done it 100% and both the equations have no error. Right? That's what is his claim. But after Heisenberg, no one has started talking with regard to certainty with subatomic particles. Rather, they were basically talking with respect to what? Probability. That's why, look into your textbook's definition of orbit. I think he will be telling that 99.99% probability of finding the electron. He's not telling in certain terms because of Heisenberg. Right? And if this is the case, here comes another theory, which is de Broglie's theory and Schrodinger's wave equation. Well, it is really surprising sometimes. Some scientists have destiny, some don't have. Right? And the de Broglie theory was basically proposed, a decade ago, when all these people were present. Right? But I think when he was actually claiming his theory, people thought he is mad and abandoned him for several years. Later, he came inside with vengeance and his theory was accepted. And what is surprising here, normally he has done nothing. He has actually done nothing. He has cherry-picked one equation, cherry-picked the other equation, and he was actually, you can basically say he's copying. And for copying, you don't get rewarded. But de Broglie has been rewarded for that. And look into this, what he is telling. Right? What is his theory says? Normally what we do in our high school is basically, when we wanted to dream about electron after your first class of your science teacher, right, you will be dreaming something like a pepper seed or a mustard seed, because the textbooks basically give you, the nucleus is here, and here is the first orbit. And if you look into you got the dreams about electrons. If I ask you also, how do you dream about an electron? I think a child out from his school or a school lecture, then I think he will be dreaming, or he's judgmental about the structure of an electron, something like that, because this is what is printed. Here is a nucleus and here is an electron, and this is what is drawn like this in your textbook. So when someone is drawing like this, and our teachers are also telling that yes, this is the electron, then normally a child of that age will be judgmental in his mind that electron is like something like a round small ball, or a pepper seed or a mustard seed type, is somewhat like this. That's what is the perception that is induced into the mind. Right? This perception has been completely changed by de Broglie. This perception about electron is completely changed by de Broglie. And also, let me tell you that once I finish off this lecture, you will be having a different perception about electron, and you will be dreaming in a different way. Because that's required rather. And let me tell you one example which I wanted to tell you. Watch carefully here. Some questions remain unanswered. Unanswered because your teachers were telling the electron is round like this, and it looks like a particle. Of course, other than the particle, I can't dream anything about electron. And there are experiments which say when the electrons are shot out in a gun, in a Thomson experiment, and when they're shot out from a gun or a source, and if a paddle wheel is put in between them, I think the paddle wheel is rotating. When paddle wheel is rotating by the flow of electrons or the stream of electrons, it can be considered as a mechanical motion, and any mechanical motion is a direct proof that it is a particle. right? So even taking a cue from that it's a mechanical motion and electrons behave as a particle, that's what the people who are drawing the diagrams as a pepper seed or a mustard seed, the electron is also dreamt like that, and that is how the electron structure has been induced in our mind. You must understand that. What happened was the electrons, when they are rotating a paddle wheel, it's nothing but a mechanical motion. So what happened was that perception has been built in or induced in our mind. That's why even the pictorial representation of an electrons in your textbook or your teachers were teaching us that it looks round, round, round or something like that. That's how we have now claiming the electron to be. But let me tell you that, let me promise you that, once the de Broglie's theory has been proposed, the perception, the way you think about electron also completely changes, and the dreams which you get about electron and their structures would be completely different. And you must be following this, and it's a must also. Because what happens was, if you just hang on the electron to be a particle, then there are several things and several cases which you will not be in a position to explain. For the simplest example, before I actually go to the de Broglie's theory, I'll give you a thought-provoking thing. I think it's a common thing. Observe carefully here. This is basically a p orbital. I want everyone's attention, please. This is a p orbital. And this is basically a lobe. That's one lobe. And this is one lobe. So you have two lobes in a p orbital, and let me tell you that this space and this space, suppose if I have an electron over here, remember that electron is a dynamic particle. It's so dynamic, it's almost moving with the speed of light, because you look into the velocity equation, it's 2.18 into 10 power 8 centimeters per second. So 10 power 8 centimeters per second is almost like 200 million centimeters per second. That is the speed of electrons. So what happens was the electron will be here, it will be moving everywhere like this. At any point of time it is not stable. Look here, the way it's moving. And let me tell you that the combined lobe 1 and lobe 2 together is called a p orbital. You must understand. So these two combinedly can be called as what? A p orbital. So you can expect this electron also right moving in this, because this entire space is defined as a p orbital. You must understand that, right? So it is roaming in both the lobes. You must understand. Now, one question which we wanted to answer, and I draw the attention of everyone, because we were basically thinking that electron is a particle, because it is rotating a paddle wheel, which is a mechanical motion. So of course we must be judgmental, and at that particular time, I think when it was rotating the paddle wheel, we all came to a conclusion that of course electron is a particle, and I'm not disputing that. Of course electron is a particle because it's making a mechanical motion. Now the issue is, if you look into this is one case where we will be not only fail but miserably fail in explanation of this case when you just hang on to electron to be a particle. Look into this case. If you say electron is so dynamic, moving with 200 million centimeters per second, then I think I wanted to ask myself that how did the electron cross over from one lobe to the other? I'm asking the question, I'm drawing the attention of everyone. Rather, observe, look into this case. You are hanging on that the electron is behaving as a particle. I'm not disputing that. But how do you explain such cases? Look into this case. If you say that the electron is dynamic, how is that the electron is crossing over from this lobe to this lobe where you don't have an opening? You don't have an opening at all. How do you explain? Basically, prima facie, I'm not getting into details of it, but I think you tell me, how do you explain this? Because how did it cross over from one lobe to the other? How did it cross over from one lobe to the other? So, remember, you have n number of such cases which cannot be explained if you just hang on thinking that the electron is a particle. Of course that electron is a particle. If you just hang on with that, you will be excluding in explaining convincingly any such cases which are given because you have n number of such cases where you just cannot explain electron being treated as what? Particle. You must understand that. Now, I know that you wanted to ask me, how does an electron cross over from one lobe to the other? Because I posed a question and you are actually waiting for the answer. And let me tell you that before I answer this, you need to have a little bit of theory, right? And that theory which I wanted to explain to you is basically nothing but the de Broglie's theory. And de Broglie's theory, and let me tell you this. The de Broglie's theory, understand, sometimes what happens is some people have destiny, some people don't have destiny. And this de Broglie, he was claiming this before anyone. Before even Planck was giving his theory and contending for Nobel Prize, or even before Bohr, I think this fellow is claiming this theory, and people didn't accept it because there was no convincing explanation. So people thought that he might be mad, and he was abandoned for several years. He was abandoned by several years. And then after these fellows have proposed this theory, he came in. And he has done nothing. He has absolutely done nothing. He has absolutely done nothing except for, copying a part of, particular theory, a part of a particular theory, and then using his own imagination and mathematics. And then, even though he has done it, he was so convincing and he was accepted by the scientific community. And of course, it is there till date. And what he is telling is absolute truth, which was not accepted when these two fellows were actually proposing their theories, right? What is his theory, right? What he wanted to tell is basically his contention is this. And I draw the attention, please. What is the contention of de Broglie? He says that, he basically says, every particle, now earlier, the same synonymous theory was proposed by Planck, but his restriction is only to photons, right? His restriction is only to radiation. But now what he is doing is, he is extrapolating to every matter in the universe. Well, I wanted to repeat this statement. This theory has some synonymous thing with regard to Planck. But Planck's theory is basically restricted. It's basically restricted only to radiation and photons. Whereas this fellow has extrapolated this to matter. When I say matter, it's applicable to you, it's applicable to me, it's applicable to a cricket ball or a football or a bus. You take anything, any matter, this is applicable. And what is his basic contention in the simplest of the words? In the simplest of the words is basically every particle is associated. I use this powerful word. Every particle is associated. When I say associated, mind you that, and associated with what? What? With what? A wave. Every particle is what? Associated with a wave. And what do you mean by association? Mind you that when he is telling association, there exists great intimacy between wave and a particle. The inference of what he is telling, because associated is a word which is reconciliatory in nature, meaning what do you mean by that? Reconciliation of what? Reconciliation of the statements which I am claiming now. Basically, you understand that there exists a great intimacy between a wave and a particle, right? And when you have such great intimacy between wave and a particle, then that is leading to indistinguishability. Because they have such a great intimacy, you cannot distinguish a wave and a particle, right? That's what his claim is. Now, if you say this, the reconciliatory part of these two statements is, I can use a powerful word where I can say every particle is what? Associated with a wave, right? So, they are indistinguishable. You must understand that that's what he's telling. Well, everyone can claim and make statements and run away. They can make statements and run away. But mind you that you need to explain through an equation. After all, we are pursuing science, right? If that is the case, and look into this, people will ask him. Already people are asking him when he was claiming that every particle is associated with a wave. People are already asking him, you mean to say that when I walk like a wave? People are asking him. They have a doubt. They are asking a question. So you mean to say, when I'm walking, man, de Broglie, when I walk like a wave? And they are asking such questions with an intent of intimidation. And someone was asking, hey man, if I'm bowling a cricket ball, is it going as a wave? Well, I can't see any wave. Well, if I walk like a wave, I don't see any wave. This is what they are asking. But let me tell you that de Broglie right? He was answering each and every question because after all, he was abandoned earlier. Now he came with a full homework. So he says that if someone is asking, hey, I walk like a wave, of course, yes, he is telling. Is a cricket ball looking like a wave? Of course, yes, he is telling with conviction. And let me tell you that, and now he has his own theory. And you know, where people, when he was proposing, there was stoic silence because he is using a part of Planck, a part of what? Einstein. And both these fellows have already received Nobel Prize. And when they are already receiving Nobel Prize, and if you tell or comment anything on de Broglie, then I think the Nobel Prize will be retrieved from what? The Planck and the Einstein. You must understand, because they have already received it. And I have done nothing on my own. I have done nothing on my own. That me means de Broglie. I have not done anything on my own. I'm just taking a cue from what? The Planck and Einstein, and I'm doing it. If you say I have done some mistake, then I think Planck has done some mistake, or what? The Einstein has done some mistake. So when he was claiming his theory, when he was telling his theory, there was absolute stoic silence, and just you need to listen to them. That's all. Listen to him. That's all. You must understand that, right? And what is his theory? What is basically he's telling? Watch carefully here. Watch. You know, he is using this statement. According to Planck, he says E is equal to h nu. That's equation number 1. And when he writes this equation, he was asking any doubt? Because what doubt you will ask? Because he's already given a Nobel Prize for this equation. You should not have any doubt, because if you have any doubt on that, you would have asked that day. And you know, all the doubts and all were cleared, and hence the Nobel Prize were received by Planck. So he says that E is equal to h nu. Is that correct? He's asking, is that correct? Of course it is correct. They have given him Nobel Prize, right? So there was no answer for that, and they were maintaining stoic silence, and that's equation number 1, right? And then he says, according to Einstein, E is equal to mc square. This is equation 2. That's equation 2. Any doubt? He says. What doubt, you will ask? If you are doubting now the Einstein equation, that means that you have to retrieve his Nobel Prize, which is already presented to him. You must understand that, right? So absolutely no doubt. This has been received the Nobel Prize. This has been given a Nobel Prize. So there was no doubt, right? And this is energy. And this is also energy. So what I will do, he says, what I will do is basically equate these two. After all, both are energies. So he says equating 1 and 2, then he gets h nu is equal to mc square. You must understand that. And any doubt? What doubt? You have done nothing. You have absolutely done nothing. You have absolutely done nothing. You have just taken a Planck's equation. No one will have a doubt in that. And second, you have taken Einstein's equation and you're asking no doubt. Of course, you should not have any doubt. And I'm just equating 1 and 2 because after all, this is energy and that is energy. So I can simply say h nu is equal to mc square. And then, if this is one thing you must understand, we know, when I say we know, it is experimentally determined quantity. It is experimentally determined. We have a proof that nu is equal to c by lambda. There is a relation between nu, which is frequency, and wavelength. And nu and frequency wavelength are related through c, where nu is c by lambda. And if I substitute that, then I think hc by lambda, if you look at this, hc by lambda is equal to mc square, right? No one should have any doubt. After all, it's a simple mathematics which is playing on, because the remaining two theories have been already awarded Nobel Prizes. So if nu is c by lambda, that's what we know and experimentally determined. So you should not have any doubt. So hc by lambda is mc square. If I can cancel c once, then I think you're basically having this equation. Observe. So basically what is happening here, if this implies, if you look into this, then it is hc by lambda, right? hc by lambda is equal to, right? H by lambda, c cancel, right? So h by lambda is basically equal to mc. Or I can find lambda. So lambda is h by mc. This is one equation. And let me tell you that what are these quantities? What are these quantities? Now suppose, imagine, a particle is moving with the speed of light. That means c is the speed of light. You must understand that, right? Particles moving with the speed of light, and the mass is 2 less, right? And h is Planck's constant. So basically this equation is for basically radiation. This is basically radiation, that people moving with great speeds of light. So if anyone is too dynamic like an electron, right? You can say electron for this. Mind you that if any particle like photon is moving with the speed of light, then you have to use this equation, and now the photon, then you can find out the wavelength of a radiation consisting of photon. That photon's wavelength can be found out using this equation. But he says that is already told by Planck. What is new? He says that if anyone is not moving with the speed of light, like say me, I walk slow, or the fastest cricket ball is around 120 kilometers per hour, and for such, they are not at the speed of light. They are not with the speed of light. I am not walking with the speed of light. So for all those, he says that you can use this equation, lambda is h by mv, where v is the velocity of that particular object. You must understand. V is the velocity of that particular object which is not moving with the speed of light. So this equation you use it for radiation, and this equation you use it for matter. You use it for all matter other than what? Radiation. You must understand. That's what he told. So what I will do is this equation, mind you that, forget about all this what he has done. The only thing is, normally when we copy, we are not rewarded. We are punished rather. There are some destined people like de Broglie. He has done absolutely nothing. He has not given any Nobel Prize, but I think he has drawn some sense into us. Because you cannot question anything what he has done. You cannot question anything you have done. Because you can't question this equation. You cannot question this equation. And then remaining is a simple mathematics. You must understand. So his contention, if I can write it, the gist and what he wanted to tell has great sense, and I wanted to list that out, and I draw the attention of everyone. Now forget about all this and watch carefully here. Watch carefully. What is his issue? What is his problem? Is this. Watch. See what his contention is. Basically he's telling for radiation, use this equation. Lambda is h by mc, where c is the speed of light, and light consists of what? Photons. And now he's basically telling through this equation, and I draw the attention of everyone. This is a great thing which was told by Planck. Now he's actually reorienting himself to Planck. After all, he has taken and used the Planck's equation, so he has to tell that, of course, great, you are Planck. You must tell him, because after all, you have used it, right? This was told already, but I think he is actually telling and reorienting himself to Planck, and he is actually congratulating him. Nothing to worry, because lambda is h by mc is basically for radiation. It implies photon, that's nothing but the light, consisting of a photon is a wave. If you don't believe it, then use this equation. You'll get its wavelength. If you claim something is a wave, you must tell its parameters. Now, what is the language of waves? The language of wave is you should be telling what is the wavelength and what is the frequency. If you are able to tell that, then I think your claim of this being a wave is, of course, justified. So, you use this equation. When I say for radiation, then he is claiming that photon is a wave. Well, this is surprising to us, because for the simple reason, because we were having one theory, Newton's corpuscular theory, where photons are said to be particles. They are said to be particles. And let me remind you, there are some properties of light like photoelectric effect. If you ask me what is photoelectric effect is nothing but a property of light. And in that photoelectric effect, if you actually see, you have a kinetic energy equation. And whenever you see in an equation kinetic energy, it represents mechanical motion. And when anyone is claiming that to be a mechanical motion, then it's a direct proof that photon is a particle. So, if you actually see the photoelectric equation, h nu is equal to h nu naught plus half mv square, which I was telling in the previous classes, right? And in that you have half mv square, which is nothing but kinetic energy, implying that yes, photon is of course a particle. Now what is new here? What is new here? He's basically telling that for photon, for radiation, you can actually calculate lambda. And lambda is a wave. Now that means that we are reconciling again that of course what? Photon has a dual nature, and let me tell you that it is a synthesis of both wave and a particle. And if you ask me now, can you draw the diagram of a photon? Because from a school student, what he will do is, when someone is asking a photon will be something like this. A photon is a particle. That's what our teacher told. That's what is our perception is. Other than this, I cannot dream anything. I cannot dream anything. You cannot, because photon is a particle. There's absolutely nothing wrong in that also. Of course, there are some properties of light where you can explain photon being a particle, and one of them is what? Photoelectric effect, and that's a question in the exam. But the new thing is, since this fellow is telling me that you can actually calculate the wavelength of a photon, so basically he's telling that the photon has a wave characteristic. If it has a wave characteristic, then I have to dream in a different way. Today when I sleep, or you sleep after my lecture, you will get the dream of a photon to be something like this. Well, I'm drawing the diagram of a photon. Drawing the diagram of a photon. Watch carefully here. Look into this. This is a photon. That's a photon. That's a photon. You say, of course, you had shown this to be a photon particle. This is photon particle. That's how anyone will dream, not only you and me. But now the new thing is, this is a photon, and this is the crest, and this is a trough, and a crest and a trough will make a wave. And the distance between a consecutive crest and a trough is nothing but a wavelength. And wavelength is a language used for waves. It's used for waves. So from now onwards, if anyone is asking you, can you draw a photon? Then you must be drawing a wave, and I call this to be a photon wave, mind you. So if anyone is actually, if this is the source of photons and if I'm shooting the photons out, they are shot as what? Photon waves, and they travel in photon waves, mind you, they travel in photon waves till the other medium absorbs it, and it's a fact. If someone is asking, come on man, what are you telling? A photon is a wave, can you explain that? We are not convinced, then you're not convinced, then I think you have a de Broglie's equation. If you're not convinced, then you tell me a photon moving with the speed of light, and I have a Planck's constant, and the mass of the photon, I think if you can add if you put substitute here, then lambda is h by mc. You must understand that. So from now onwards, when I wanted to dream, when I go to bed, I think I should dream the photon to be a photon wave. Don't think that the photon will be having an eye and a nose like a human or something like that. The way you have judged the photon to be a particle, fine. That's how it looks like. But photon behaving as a wave, of course, yes, you have to draw like this. That is how the photon will look like. You must understand, of course, convincingly, daringly, you can draw a photon wave. You must understand that. Right? That's for radiation. Similarly, for all other matter, excluding radiation, that's for you, for me, a cricket ball, a dust particle, a microparticle, or whatever, except for subatomic particles. Subatomic particles are invisible. For all that, use the first equation. But remember, not even subatomic particles. I withdraw that statement, what I was actually telling. No, for radiation you use that one, but remaining all matter, whether it's a cricket ball, electron, proton, all right, all other particles, excluding the radiation thing, I think you can use this equation for all other matter. This is h by mv. You must understand. For all other particles. And believe me, if someone is telling that, yes, I am walking like a wave, I am not disputing it, I will tell him that, yes, of course, I walk like a wave. But the only thing I will ask him, tomorrow someone is asking you when you are actually walking in a corridor, and he calls by your name and say, hey, you're walking like a wave. Then you ask him in reverse, what's my wavelength? So when you actually tell the wavelength, then you are convinced that yes, you're walking like a wave. You must understand that. Got my point? So don't dispute it. For all other matter, that is lambda is equal to h by mv, you must understand that, right? Now, in case of what? Suppose if it is electron, that's about photon. What about electron? Now our teachers in the 10th class were telling us, electron is like a pepper seed, mustard seed, and when they are drawing, here is the nucleus, here is the first orbit, and here is the electron. That's how it is shown as an electron. You must understand, am I disputing it? Absolutely not. Absolutely not. Of course, the electron is a particle, because you can actually see in the Thomson's experiment, the electron beam is actually rotating the paddle wheel. It's rotating the paddle wheel, and I think it's a mechanical motion. And of course, electron is what? A particle. There is absolutely no dispute in it. Now, the other thing what we forgot is you cannot be judgmental alone that electron is a particle. Now, electron is a wave also. Now, if you look into this, for all other matter, including electrons, the lambda is h by mv. That means that electron is a wave. So today, after my lecture, after de Broglie, what he told, when you're going to bed, and if you wanted to dream about electron, then the electron must be dreamt like this. Watch carefully here. This is how the electron looks like. This is what an electron looks like. That's an electron wave. So today I'm dreaming electron to be, not like that. Of course you can dream that, but I think the new dream which you must be inducing in your mind and be judgmental also is basically, this is how the electron looks like. This is how the photon looks like. You must understand. So I can simply say electrons or even the photons, both are synthesis of both wave and a particle. Mind you that. Let me tell you that no one can absolutely hang on to a particle. No one can absolutely hang on to a wave. You must always tell they are the synthesis of both wave and a particle. You must understand that, right? Now we started off with a case. Why all this has cropped up? We started off with a case, and we would like to explain that case for you. Watch carefully the first case, what I was telling. So before I actually rub this, I want to draw your attention. Please understand that this equation, you use it for photons, and this is how the photon looks like, right? It has a crest and a trough. That means it has a wavelength, and that's how is the photon wave must be dreamt on from this second onwards when you go to sleep, right? And similarly for electrons, you must be dreaming it as a wave with both crest and trough. So I can simply say that if someone is showing you this and asking is it a wave or a particle, you slap that fellow first. You slap him. And he will ask you a question, why did you slap me? Then I think the answer would be every particle is associated with a wave, and there is a great intimacy between a wave and a particle, and this intimacy is leading to what? Indistinguishability. That's why every particle is associated with a wave. These are the three synonymous statements you must be telling to the fellow who got slapped by you. So this question is ridiculous, and if someone is asking, he is ignorant of what we know. Showing something and asking you, is it a wave or a particle, is absolutely ridiculous. That questions must not be answered, rather get slapped and explain them. Right? And here is the first case where we started off, and I want to explain that case now. Watch carefully here. Look into this. I wanted to redraw again this one. This is a lobe. That's a lobe. lobe, and this is a lobe. And together this is called a p orbital. Together this is called a p orbital. Now we wanted to answer if there is an electron here, and this electron is moving with a speed of 2.18 into 10 power 8 centimeters per second. That means this is too much dynamic. It is basically too much dynamic. It's moving so fast. It's moving so fast. And then, how is this electron moving from this lobe to that lobe? How is it moving from this lobe to that lobe is an issue. You will not be in a position to explain when you just hang on that electron is a particle. Now you have to dream differently. Now it is so easy. It is so easy to explain how electron moves from one lobe to the other. It is so easy when you think that electron is a wave. And look here, it is so easy. This is the electron wave, this is the crest, and that is the trough. Or you start from here, this is the crest, and this is the trough, and you explained it. If you hang on that it is a particle, then you will be struggling. How does it go from here to here? You don't have an opening here. You don't have an opening there. How did it cross from one lobe to the other? It's difficult to explain. So you have n number of such cases where you will be missing or couldn't explain or fail miserably in case if you don't dream that the electron is like a wave. You must understand that. Right? In this case, how is an electron moving from one lobe to the other? I think it is moving as a wave. This is the crest and that is the trough, and I explained it. You must understand that. Right? As every theory has significance, because one thing which I am not convinced, one thing which I am absolutely not convinced is, well, someone is telling that, you walk like a wave. I am walking like a wave. Well, I am watching cricket matches where someone is bowling with great speeds, but I still see the ball, more as a particle. Well, I am not convinced that the ball is moving like a wave. Even the best of spinners in cricket, when they bowl or spin the ball, I think we still consider, or I consider, or we dream that ball to be, of course, what? A particle. I'm not convinced when someone is telling me that when I walk like a wave. Now, how do you go for such an explanation? How do you explain such things? You must understand that. There are so many such cases. Such cases could not be explained if you just hang on that electron is a particle. You must understand that. So this is a simple explanation. Earlier we thought that how is an electron crossing over from one lobe to the other? It becomes so simple when you actually treat it as a wave, and then you can simply say it's a crest and it's a trough and it's an electron wave which is crossing. It's not a particle for which you require an aperture here such that it moves from here to here, because after all electron is a dynamic particle. You must understand that, right? So if this is the case, there are some things which are not convincing, which are absolutely not convincing. Because, someone, calling me, in a corridor and say that you go away, and when I'm walking, he claps again and tell me that you are behaving as a wave. I'm not convinced about it. And I'm not convinced about a dust particle also. Because we see dust particles flowing and we can see with the naked eye, and someone's claiming that it's moving like a wave is also not convincing. Cricket ball moving like with the great spinners being bowling also, I don't find it as a wave, because I can see the ball, very much in my mind is not accepting it. Rather, by treating it as a wave, especially me, walking like a wave is something which my mind is not accepting, man. But I think prima facie, cricket balls, dust particles, right, me, a bus, a car, or anything like that, you telling me that it's a wave is absolutely not convincing. So how do you address such issues? So what I mean by this is any theory of such level, when you propose it, it has significance as well as insignificance, right? Insignificance to that extent that no one can measure it. What I mean, if I can illustrate this to you, well, I'm illustrating this to you. Watch carefully here, right? The theory has significance as well as what? Insignificance, you must understand. What is the significance of de Broglie's theory? Watch carefully, significance of de Broglie's theory. significance of de Broglie theory? What is the significance is, people have discounted something, man. Till he proposed, it's a very great theory rather. Great proposal by de Broglie. I am actually convinced, and I'm happy that I'm telling you such a thing if you're listening to me for the first time. I take this privilege of de Broglie's theory being explained to you. And let me tell you that, the significance of de Broglie is, we will now treat the electron to be a wave. Till date we have not done. Electron is a wave. People have discounted it. People have just hanged on that the electron is a particle. They have discounted it. Electron is a wave has been discounted. And de Broglie is telling now, how dare you do it? How dare you do it? Especially electron. Why? What is the speciality of electron? The speciality of electron is, first of all, its mass is negligible. It's 10 power minus 28 grams approximately. And the speed at which it moves, it's so dynamic. It's almost 200 million centimeters per second. And for an electron with great speeds, an electron with a negligible mass, no one has got a thought that electron can behave as a wave. Even if it behaves as a wave, that has been discounted. It has been discounted. Very unfortunate. He was actually telling this from several years and he has been abandoned. Well, I'll tell you why you should not discount electron to be a wave. You must not. You should not. Because I will explain this through an equation. I'll explain this through an equation. Through a problem rather. Look into this. Look into the significance. The significance is, let us take the case of electron. Let us take the case of electron. What is the case of electron? The mass of electron is 9 into 10 power minus 28 grams. Such is the mass. 9 into 10 power minus 28 grams. And let me tell you, it moves with the velocity somewhere 2.18 into 10 power 8 centimeters per second. 2.18 into 10 power 8 centimeters per second, which is almost 200 million centimeters per second, is the velocity of the electron. And how dare people have discounted to note down this, calculations. How dare you do it? This is not a point for discount. So what I will do, if I can substitute this in de Broglie's equation, substitute this in the de Broglie's equation, when I get the value, well, I want to shoot all the scientists before this. How dare you have done? Sometimes, scientists behave silly. They behave silly. And this is the case of being silly. Because, how dare you actually discount it? If I substitute in the equation of de Broglie H by mv, look into this. This H value is a Planck's constant, 10 power minus 27. Right? That is a value of what? Planck's constant. Divided by the mass of electron and the velocity of electron. And the mass of the electron, if you see, 9 into 10 power minus 28 grams multiplied by its velocity 2.18 into 10 power 8 centimeters per second. And people who are good at mathematics at this point of time, they are angry. They are angry because people are silly. People are silly. They just thought the electron is a particle like a pepper seed or a mustard seed, which is actually printed in your textbooks. How dare you discount it? Now what is that they have discounted? What? Look here. Look here. This is approximately, I can simply say, if I approximately cut this to be 10 power minus 27 and 10 power minus 27, 9 I take it to be 10 and finish it off for our explanation purpose. This is 10 power minus 27 and this goes approximately 3 times. Approximately. So this is actually having 3 into 10 power minus 8 centimeters. Come on, man. Come on. Come on. What is this? This is the wavelength which is having a value 3 into 10 power minus 8 centimeters. Come on, man. This is basically the wavelength of electron. That is the wavelength of electron. How dare you discount it? How silly you can be. Why I am shouting? For the simple reason, look into this value. This 3 into 10 power minus 8 centimeters is the wavelength of X-rays. The wavelength of X-rays. It is within the reach of the wavelength of X-rays. Where X-ray is a wave, if X-ray is a wave with the same wavelength as the electron, how dare you discount it? How silly you can be. How silly you guys are. This is not the value. 3 into 10 power minus 8. This is 3 into 10 power minus 8 centimeters, which is wavelength of what? Wavelength of electron. Wavelength of electron wave, which is similar to wavelength of X-rays. When X-rays can be treated as a wave, then an electron wave with the similar dimensions, how dare you discount? This is looking silly. When I'm actually lecturing this, when someone, De Broglie, was lecturing this and illustrating this to the public, to the crowd, there was stoic silence. You cannot question me. If you question, then you are questioning Planck. Then you are questioning Einstein. But both have received Nobel Prizes. I have done nothing. I have absolutely done nothing. I have just used both of them to have this equation. To have this equation. And when I'm substituting the electron parameters, I'm getting this value. This value. And this value, of course, is a calibrated value. When I say calibrated value, that means they can be measured. That can be measured by an instrument. Why you should measure first? You need not. It's actually within the parameters of an X-ray, man. When someone is within the parameters of the X-ray, then what is stopping you to electron to be dreamt as a wave? Well, I'm so convincingly now draw the electron. If someone is asking me draw electron from after this theory, what I told, someone is asking me draw electron, then I think I'm drawing an electron. That's electron. That is electron. But our teachers told that, it looks like a pepper seed, mustard seed, small. Ridiculous. It's not ridiculous, but you can't hang on there itself. So, you cannot question me. The problem is you have to listen to me. That's all. You have no other option. Listen to me means not me, De Broglie. Because I have done nothing. I've just copied the Einstein equation, copies the Planck's equation, and just substituted the parameters of the electron. Then I'm getting into the dimensions of an X-ray. Silly people you guys are. You are so silly. You discounted me when I was actually telling you all this. Ridiculous. Right? So the significance, now what is the significance of De Broglie is, of course, I can simply write it in a box. This theory applicable only to microparticles. Microparticles like electrons, dynamic particles, microparticles in the dimensions of this much weight, this much mass. It's not applicable to you and me. Suppose if I apply it to me. Let's apply to myself first, right? Now this is a significance. This is significance. And once I say significance, this significance must be noted down, and you must be dreaming today when you go to bed, the electron to be a wave, which has a similar dimensions as an X-rays. Now what is insignificant here, and I want the attention of everyone. And I want the attention of everyone. And I want the attention of everyone. Watch here. And I can claim de Broglie insignificant for macro bodies. Macro bodies. Let's take the case of a cricket ball. Well, I can tell you, for the cricket ball, let it be 100 grams. Let it be 100 grams. And it moves with the velocity of the cricket ball. Velocity of the cricket ball, let us say it is moving with 100 centimeters per second. Not more than that. You can't move with an electron. With the speed of an electron, which is 200 million centimeters per second. Will the cricket ball move with that? No, absolutely not. It moves with 100 centimeters per second. Assume. Then if I put it, lambda is h by mv, then it is 6.6, the Planck's constant, divided by the mass of the ball, 100 grams, which is 10 square. And the velocity is also 10 square. So ultimately you are left with what? Come on, man, this is 6.6 into 10 power. This is minus 31 centimeters. That is the wavelength of the cricket ball. Wow. Great. That means this cricket ball is also like a wave. But this value is ridiculous. Insignificant. Because if you feel 10 power minus 31, what is 10 power minus 31? 0.000000000000000 up to 31. Now come on, this value seem to be uncalibrated. Uncalibrated means cannot be measured by any instrument. Cannot be measured by any instrument. Negligible. So, at the same time, remember, the same thing, we were actually doing it for electron. And the electron value is coming within the range of what? X-rays. There you can't discount it. So, it is significant. Here, when the value is 10 power minus 31, such values cannot be measured by any instrument because you cannot divide that or calibrated in any instrument. You must understand that. When it is not calibrated by any instrument, this becomes insignificant. So simply speaking, I can say simply speaking, de Broglie significant for electrons and microparticles, microbodies, and de Broglie insignificant for macro, that's balls or even dust particles. Dust particles, you must understand that, right? So that's what is the de Broglie's theory, and I want to appeal something to you. Now, after de Broglie's theory, I want you to get dreams when you're going to bed. Two dreams you must be getting. One, electron must be dreamt as a wave, along with particle. The particle dreams already you have. Don't erase it. Of course, it's a particle. But at the same time, the new dreams should start. The electron must be dreamt as a wave. And the photon is also a wave. In fact, photons and electrons are synthesis of both wave and a particle. Right? That is how, that's for today's lecture. And I have an appeal. Remember that you can bank on us. Who are we? We are T1 channel, Tone Academy, and we host the best lectures for you, for all the students of the 11th and 12th, right, who missed their classes back home, or who cannot afford the lectures in a particular college, then I think you can bank on us, because we will be following a sequence for you. We will be following a sequence for you. Do subscribe for the T1 channel of the Tone Academy. And I'm Chandrasekhar Vadlamani signing off for this time. And I'll see you in the next class, and we'll be discussing the Schrodinger's wave equation. Let us see what exactly is. Thank you very much.